That means that how tight is the dependency between the module or between the component. Okay, so there are three common types. Content component. Okay, means that this content component means that one module, okay, can amend the content, internal content of another module. Okay, common coupling means that the dependency, let's say for example, between the dependency on the global variable. Okay, data coupling is referring to the data parameters. Okay, data parameters. Let's say for example, function A pass certain parameter to functions B. You get here, okay? That already exists data coupling already. Understand? Okay. Cohesion, how the module functions work together to achieve a single task. Okay. So cohesion can be classified into this form: functional cohesion, procedural cohesion, temporal cohesion, and communication cohesion. Functional cohesion is how functions put together to perform a single function. Procedural, okay, how the step, okay, to achieve one task. Temporal cohesion, okay, all the tasks in the design, okay, all the tasks in the design to perform a specific, how the task is being performed within a specific duration. Okay, so this is the temporal cohesion. Communication cohesion, okay, is how the task consume the same data or produce or output the data. So the idea is high cohesion now, okay? And separation and interface and implementation. So this is what we have discussed just now, okay? So one one method, okay, or may have different implementation, or one task may have different implementation. Okay? So this is sufficient incompleteness. Make sure your component, okay, able to capture all the necessary information. Okay? Completeness, how is your design able to achieve most of the specification? And sufficient, okay, providing the necessary service to the user. Okay? Separation of concern. This concern actually is an area of interest, okay, in the system. Okay, for example, security. Let's say authentication. You know authentication, no? Authentication means that to check whether user have the authority to access certain content in the system, or certain part in the system. That is authentication. Okay. So now, and this authentication may happen. Let's say I have a sales and inventory system. Okay, sales system need to every time the user want to access something, he need to check also. Am I right? Inventory system access something also need to check also. Am I right? Okay, actually the function is the same function. Am I right? The same function. However, he will appear, he is needed to perform his task, okay, in different part of the system. You get me? In different part of the system. So therefore, okay, you need to be very careful when you design a system. Okay, if you are meeting this kind of concern. Understand why? Because imagine sales system need authentication. Inventory system need authentication. Okay, logistics system need authentication. Are you going to have create three authentication module for that? No, right? Am I right? Okay, then how are you going to separate this authentication module from these three modules? How are they being executed? At which point they are going to execute? You understand? Okay, you need to concern on that. Okay, you need to consider. Okay, so this is the concern. Construction design. Construction design is after the detail design. Maybe you start to write the algorithm, okay, or maybe you start to code already. Then sometimes you find that something is not correct. When you code or when you write the algorithm, you look back at the design, you go, something may not be correct, something may be missing. Understand? Something is missing. Then you have to design, okay, or modify back the missing part or adjust back the incorrect part. Construction design. Understand? Okay? Construction design. Okay? But however, some people they put creating the algorithm, writing the algorithm into the construction design. Understand? Okay? So construction design normally is a small scale modification. Okay? You can see that apply in a small scale of algorithm, data structure, and interface. Okay, settle. This is our chapter 2. Any question? Any question? Any question? Ask. Just now I saw one student has left already. Okay. You see? I saw one student left. Still got two students didn't come. Yesterday, who didn't come? No, I mean yesterday practical. Okay. Why still you student now? Still got two students. One didn't come, and then who is another one?
Same as we now, same
Doing part time. Okay. So okay, settle for question chapter 2. Any question, class? Any question for the detail design? Understand or not? Understand or not? Understand, class? So that's why when teaching this subject is very simple. Okay, so understand or not? Yes, that's why Sam, Emma, understand? Okay, then how about at the back? Understand? This side, understand? Understand now? Cannot say don't understand one now. No. And understand not? Yeah.
Top stand.
Huh?
Top stand.
Oh, top stand.
No.
Okay, so maybe we take 5 minutes break, then we cover a bit on the chapter 4.
4.
Okay, I don't think that we cannot cover all that. Okay. After chapter 4, we are going to come back to chapter 3. Okay, because your midterm cover on chapter 1, 2, and 4. Part of the 4 lah. 4 is, I think, is until the middle way lah. Okay, I guess it's until middle way. Okay, so yeah, and then your midterm got 2 questions only.
Drawing diagram.
Your midterm 3
在上厕所。
Your midterm got 2 questions. Each question 25 marks. So total is 40 marks. Total is 50 marks. Okay, and your midterm is 40% of your coursework. Understand? Okay. And then that's it. So your midterm will be on the week 3, 4, 4 o'clock.
Here.
At here, yeah. So, is it possible for you to sit, have a space in
No.
between? Huh? I think can.
Is it possible to let us
Okay,
see?
so
So you can overgo.
after the exam. Okay, so normally not difficult one.
Really? So you give some guidance.
Yes, I got mine.
I don't know lah, maybe sometimes so many years already, not so many years, so many semester is starting the question maybe it's already immune to the difficulties level. You get me? Okay. So okay. So if you want to go for to the restroom, then you can have this, okay, for the restroom. We are going to start our 5 minutes already. So fast. You see my time in this yeah. Okay, because the chapter 4 got how many slides? 70 something slides. Okay, we need 2 days at least. But however, I guess we can complete hopefully by next Wednesday. Wow, in this case then we have to we may make additional tasks. One thing is your chapter 9. Chapter 9, okay, is a very, very huge chapter. Okay, 100 something slide, okay. But that chapter okay, actually is a reference for your practical. Understand? If you want to know what is class diagram, what is activity diagram, you can go to the chapter 9 and have a look on that. Understand? Okay? But this chapter 9, we are going to discuss also, but however, I'm not going to discuss one by one, in very, let's say line by line one, because it's already covered in the practical. Understand? Okay? So it's a reference chapter, so you can refer back. Okay? If you don't understand a certain diagram there, okay, you can refer back to chapter 9. Okay? Even though your chapter 9 I put as a PowerPoint slide to you. Why? Because cannot convert to PDF. I guess the file is too large already. Okay, too huge already. Yeah. So this semester, I guess you only take 2 subjects only, right? So happy.
Not happy. Other course more than that.
Got other course now?
I mean other program.
Are you sure?
Yeah.
Two subjects only or 2 course? 2 subjects only or?
The two MPU. One
MPU
MPU, one main course. So they're more free.
Or maybe they set the same for the MPU subject. Software engineering is very challenging one. Okay. But it's very interesting. Yeah. You learn a lot of things. Okay. And only slide this one. Wow, so many. Look at complicated one. 56 slide. 56 slide. Definitely today cannot complete lah. Chapter 4. Okay, so I guess we shall start. Now, chapter 4, key issue in design, in software design. So when we design a system, okay, we may face a lot of issue there. Okay, let's say some of the issue may be the quality issue. Let's say the speed, reliability, okay, the performance, the availability, okay, of the system. So these are some of the issue. And then another type of issue, okay, which is, let's say for example, hardware, software, and so on. And then there is other type of the issue that is not directly but is related to the system also. Let's say for example, this is the issue here. Concurrency, control handling of event, data persistence, distribution of component, error and exception handling, fault tolerance, interaction and presentation, security. Understand? These are some of the what you call other issues. Okay, so you can see that for the overview of the software design. Okay, so normally what we face is okay, how are we, for example, how are we going to decompose the system? How are we going to group the functions? How are we going to decide what are the classes inside the system? You get me? Okay, so this is all the issue also. Okay, how many level of design we need? Okay, so let's say just I mentioned the quality, okay, and some this any lots of issue you may face, and then okay, these are some other issues that may affect the system also. Okay, so normally, okay, so when we try to create a system, okay, we try to emphasize the functional decomposition. However, functional decomposition actually is normally referred to the traditional software development. Okay, if we use object-oriented, it's not functional decomposition already. Okay, we identify the object and the function. Understand? So, and then you need to identify, okay, each subsystem, okay, what are the subsystem exists? How many subsystems should have? You get me? Okay, and then how are we going to break the subsystem into a smaller subsystem or so on? And then what is the design goal? How are we going to meet the goals? And then what kind of approach we are going to use? This is traditional development, we may face this issue. However, other issue besides the quality, let's say for example, just now I show you this other issue. Okay, this other issue is not, how to say, is not clearly, directly we define in the specification one. But we've done it, then we realize. And then this other issue may cover, may affect different modules across different modules or affect different stakeholders also. Understand? Okay? So it's when we affect different modules, okay, and then maybe these so-called issues they may need to be implemented over different modules. Okay? It means that cross-cut different modules. Understand? Okay? So then you have to be aware that how are you going to design when for this issue, and what are the things you need to care about that? Okay, what are the things you need to consider when you design for this type of issue? Okay, so and this type of issue we call as a aspect. Okay, aspect, and then we have in chapter 3. When we go back to chapter 3, we are going to have an introductory on the aspect-oriented design. Okay, aspect. So this is what we call the aspect, and the key issue here, concurrency. Concurrency is not in the functional requirement one, am I right? Okay, when you do this one, let's say a banking system or inventory system, then you can imagine that how come if I have 10 staff to use, 10 computer connect, how if 10 computer connect to the same data or connect to the same module, then what is the effect? How am I going to do this? And you get me? Okay, let's say for example, word processing, okay, Microsoft Word, when I type, then I type one word wrong, Okay, then it automatically detect spelling mistake. Am I right? The red color spelling mistake. Okay, so how am I going to implement this checker? Am I going to ask the user, okay, check spelling? No, it's automatic one, Am I right? You see? Okay, so these are other issues you may consider also, you may face when you're doing your design. Okay, it's not as simple as you just meet the functional requirement, meet the non-functional requirement. Understand? Okay, so there are other issues to consider, especially when you're going to create a system, a distributed system. That is much more challenging. You get me? Okay. So now we come to the first issue first, concurrency. What is mean by concurrency? Concurrency is okay. Concurrency is those things that happen at the same time. Understand? Or those events, those functions, those procedures that happen at the same time. Okay? Now, concurrency is the tendency of things to happen at the same time in the system. Okay? It's a natural phenomenon. Okay, in real world, okay, in the real world system, okay, at any time, okay, any second, there may be a concurrency process to happen. Understand? Okay? And how are we going to handle this concurrency process? How are we going to design this concurrency process? Think of that. Understand? Okay? So, how are we going to monitor this concurrency process? You get it? So, normally in software design, yes?
The chair properly.
What is? Hey, yeah.
Give me a jump scare, yeah, suddenly wake up.
Are you scared?
Hey, I scared
Okay.
more than you. I think my ass gone already at first.
Is there anything fly over me? I feel something touching me. Oh, yeah.
它那种这种灰端。
I don't know. Suddenly I feel something touching me.
The cable is it?
I don't know. Hopefully it's the cable. Okay. I prefer to strongly believe that it's the cable to touch me. Okay. Okay. So now continue. Okay. Let me drink some water first. Let me.
Don't worry, so Halloween is already over. 鬼门也关了。Oi.
Luckily, I didn't shout until the next door here. Okay. So, okay, continue. Okay, so normally in software design, concurrency, okay, is we try to split those functions which run to concurrency, okay, into a different independent module, unit, or even though component or functions. Understand? Okay, so that when we want to call it, then we can anytime, then it can be called anytime. Understand? Okay, then it's necessary also for as a developer, you need to identify which function, okay, is a concurrency function or method or which process. Understand? Okay, so example, the spelling check, the spell checker for the word processor. Okay. So when dealing with the concurrency issue, okay, look at these two aspects, which is very important. Okay, so your system, okay, is not system. Okay, the concurrency is being able to detect and respond to external event occurring in a random order, because certain concurrency process happen because it react to certain event. Let's say for your Microsoft Word. Okay, when the spelling checker is going to identify the error is when the user type wrongly. Am I right? Okay, you can type wrongly anytime. We don't know. Understand? So this function should be your system or the function should be able to detect and respond to those events okay, that occur which will raise to the concurrency process one. Understand? So second one, ensuring that the event are responded to in some minimum required interval. You should be respond within certain expected time interval. Let's say for example, within 1 second or within 10 seconds or whatever. Understand? Okay? So these are the two important issues that aspect that you will consider. So if you are able to separate the concurrent activity in independent functions, okay, so therefore it can be achieve a truly parallel fashion, okay. But however, the challenges in designing the concurrency system is because of the interaction between the concurrent activity. If there is 2 or 3 process or functions run concurrently, okay, then you need to be taken care of. First thing is, are they going to stop together? Okay, which program, if not, which process or which function should stop first? Is there any data pass among this concurrency function or processor? You need to think of that. Understand? Okay. When is this concurrent process is going to start? What are the events is going to trigger this thing? Not simple one. Understand? Then another thing is how many concurrency functions is allowed? Because too many concurrency functions allowed, maybe your computer not sufficient memory. You get yeah, okay? So and then any multi-threaded system can be considered a concurrent system. What is meant by multi-threaded? Multi-threaded means that a system can perform multi-tasks at the same time. Let's say in Java, I guess, have you learned threads? Java thread? Thread. Got learn? Java thread, okay, you can use Java thread to create different threads and you can execute the thread in any time we want it. Okay, each thread is a single independent looking activity. Okay, so multi-threaded system can be considered as a concurrent system. And this one, a concurrent system has the following characteristic. You have a clear input and output, okay, and then the concurrent system internally consists of the resources, for example, the hardware module, okay, which are able to process the system input and generate the necessary output. And then the concurrent system, okay, consists of one or more execution steps to process the input. Understand? Okay? And then the resources of the system and their relationship are identified by the system analysis. And then the property of the concurrency, okay, determine the constraint between the steps, okay, which define the system concurrency behavior. Okay? Concurrency design goal. What? When you want to design a concurrency system, what are the goals you need to meet? Easy to understand, okay, so that the intended concurrency can be implemented and verified quickly. Have a solid system concurrency kernel to adapt the system environmental changes. Have a good scalable architecture to adapt new requirement changes. So these are the design goals for concurrency. And continue. Okay, the concurrency and throughput is well understood by all the developers. Understand? Okay? Different system concurrency can be achieved by different execution of configuration. Okay? Without serious interruption to each other and to the system reliability. Common concurrency issue or concurrency common issue. Okay? Actually, all these issues actually is more on the understanding on concurrency. Okay? It's either by the developer themselves, it's either by the marketing team. So let's have a look on the first one. The team member is not experienced in concurrency design. Okay? So most engineers have knowing the threads critical semaphores and events, but in order to design it, okay, it does not guarantee that this concurrency process or functions can be run well. Okay? And then the understanding of system concurrency is very slow. You need to understand each concurrent process, how is it, okay? You may take time, understand, okay, based on experience, okay? So maybe you cannot have a full picture of how this concurrency process is working and so on, okay? And then the marketing team, they have wrong throughput that, okay? So they have wrong understanding, okay, on the system resource constraint, complexity of designing the what we call the concurrency process or concurrency system. Understand? Okay? So almost all design do not have a clear distinction between the code controlling the system resource operation and the code performing the system resource concurrency. Okay? Do not have a very clear distinction or separation of differences between how you going to separate out, okay, those code you control the system resource operation, common system resource operation, and those code to control, okay, the system, the concurrency process. Okay, so these are the problem here, and concurrency architecture is difficult to understand. Okay. So the manager and software engineer mistakenly think that object-oriented analysis of concurrent hardware module will guarantee a good concurrent software. So it means that they said, when we want to do concurrency, okay, we apply object-oriented, okay, analysis, then we can achieve a very good concurrency design already. No, not necessarily. Understand? Okay? Okay, that's it. For concurrency. Any question? Any questions? Yes? I think your friend is waiting outside. Is it? No. Okay, no questions. I guess we can dismiss now.
What are the important parts of concurrency? The more important parts.
Concurrency, important part, you need to understand what is meant by concurrency. Okay? What is the concurrency design goal, and then what is the common issue in concurrency design. Okay, so that's it, and then control and event handling, this one next week. Okay, so please go back and read through the notes. Any questions, ask me next week. Okay, and don't forget to sign attendance. You still have 2 minutes to sign the attendance, 271053. Okay? Yeah. Anything else? Nothing, then we can dismiss already. Okay. So, class end, yeah, we can dismiss already.
你的爱情啊，
这是要尾声，
尾声的爱情，尾声你的爱情。那个是我，讲讲一个，
看了一眼之后，因为
Monday class still on, tentatively still on the Google
然后是，
我是想象我自己
然后是吧，
给想
是头发， 所以有条问题。
but still remain as the same,
不是。